In this week's lab, we were required to build a microphone and demonstrate its operation using an oscilloscope. The materials and equipment used for this practical were the following: a hollow tube, 2 magnets, cling wrap, some coil, and some tape. The purpose of this lab was to build a microphone and show it works by using an oscilloscope. The main thought behind making a working microphone was using vibration. We know that speaking creates sound waves, which is how microphones pick up any type of sound. So, we had to construct something that would vibrate due to sound waves. For this experiment, there wasn't really any uncertainties, as there was little to none calculations made. Looking back at some physics we learned, we know that a magnet creates a magnetic field as follows. This is a dipole, so there's a north and south end which either attract or repulse. This being said, Faraday's law states that any change in the magnetic environment of a coil will cause a voltage, EMF, to be induced in the coil. So, if we have a coil and 2 magnets, the magnetic field created by the magnets will cut through the wires in the coil, which induces an electromotive force and current starts flowing. The current gets induced in the coil due to the change in flux. This is done due to the vibration as it moves the 2 magnets, which gives a change in flux. Now that we have a decent understanding of how we could approach this practical, it was time to create the microphone. We started by wrapping the end of the tube in the wire provided. This created a coil around the tube. Next, we put glad wrap at the end of the tube. The glad wrap acts as the diaphragm for the microphone. After putting the glad wrap on, we put one magnet inside the tube and the other outside and let them connect to each other. This is so the magnets can create a magnetic field that gets cut through by the coil due to it moving back and forth from the vibration. Now that the microphone was built, it was time to test if it worked. We got the 2 ends of the coil and connected it to the oscilloscope. We then messed around with the settings so that we had the time at 5 ms and the voltage at 2 mV. As we spoke into the tube, we noticed an increase in the amplitude of the wave displayed on the oscilloscope. The vibration from the sound waves produces an electric current which flows out from the coil into the oscilloscope. As a result, sound is converted into electricity. Now that we got the microphone working, we can use the oscilloscope to get the frequency. To calculate the hertz per second, we use the fact that the oscilloscope shows the time between 2 peaks as 10 ms. To get milliseconds to seconds, we first multiply 10 by 10 to the negative 3. Now we have the units in seconds. To get the hertz per second, we multiply the time by 100 to get 1 second. As a result, the frequency of the microphone is 100 Hz. Here is a video of how the setup looked like and how the oscilloscope showed the sound was being picked up.
So now you
This experiment has shown that using 2 magnets, a tube, copper wire and cling wrap, you can create a microphone, which is demonstrated to work using an oscilloscope. The objective was to show, using an oscilloscope, that sound would be picked up using the given materials. This was accomplished by creating a microphone and speaking into the tube, which was proved to work by observing the oscilloscope.